Today we will be finding the sum from 1 to infinity of 1 over k squared using a different strategy. And to start off, we will consider the natural log of 1 minus e to the I theta. By definition is negative the sum from 1 to infinity e to the I k theta divided by k. And we know that e to the I theta is the cosine of theta plus I times the sine of theta. So replacing this here, we have the natural log of 1 minus cosine theta minus I sine theta is negative the sum from 1 to infinity of e to the I k theta over k. And we could rewrite this as the natural log of the modulus of 1 minus cosine theta minus I sine theta plus I times the principal argument of 1 minus cosine theta minus I sine theta is negative the sum from 1 to infinity e to the I k theta over k. And then taking the imaginary part on both sides, we have the principal argument of 1 minus cosine theta minus I sine theta is negative the sum from 1 to infinity of the sine of k theta over k. And the argument of 1 minus cosine theta minus I sine theta is the same thing as the arctangent of negative sine theta over 1 minus cosine theta. So we have the sum from 1 to infinity sine k theta over k. And from here we will utilize some trig identities. And we know that 2 sine theta cosine theta is the same thing as sine of 2 theta. And we also know that the cosine of 2 theta is 1 minus 2 times sine squared theta. So now letting theta go to theta over 2, we have twice sine theta over 2. Cosine theta over 2 is the sine of theta. And for the second one, cosine of theta is 1 minus twice sine squared theta over 2. So now we have a cosine theta minus 1 is negative 2 sine squared theta over 2. And putting the negative, we have 1 minus cosine theta is twice sine squared theta over 2. So now using this and putting it here, we're going to have the arctangent of negative 2 sine theta over 2 and the cosine of theta over 2 divided by, we're going to have a twice sine squared theta over 2, and this is equal to negative sum 1 to infinity sine of k theta over k. And these twos end up canceling. One of the sine thetas end up canceling, and we know that cosine over sine is the cotangent. So we have the arctangent of negative cotangent of theta over 2 is negative sum from 1 to infinity sine of k theta over k. But we know that the arctangent is an odd function, so we could put this negative to the front and make this positive, but these negatives end up canceling. And we also know that the cotangent of theta over 2 is the same thing as the tangent of pi over 2 minus theta over 2. So we're going to have the arctangent of the tangent of pi over 2 minus theta over 2, sum from 1 to infinity, sine of k theta over k, and those end up canceling, so we have now the sum from 1 to infinity, sine k theta over k is equal to pi over 2 minus theta over 2. And now from here, we will integrate both sides with respect to theta. Now we're going to have the sum from 1 to infinity, negative cosine k theta over k squared is equal to pi over 2 times theta, then minus theta squared over 4 plus some constant. And from here, we'll let theta equal 0. So we're going to have the sum from 1 to infinity. Cosine of 0 is 1, so we have minus 1 over k squared. And this is end up equaling c. But since we know this is equal to c, we could just plug it in here. So we're going to have the sum from 1 to infinity, negative cosine k theta divided by k squared is equal to pi over 2 theta minus theta squared over 4, and then minus the sum from 1 to infinity, 1 over k squared. And now all that's left is to let theta equal pi. So letting theta equal pi, we're going to have the sum from 1 to infinity, negative cosine k pi over k squared is equal to pi over 2 times pi minus pi squared over 4 minus the sum from 1 to infinity of 1 over k squared. And we know that the cosine of k pi is the same thing as negative 1 to the k, but adding an extra negative sign would end up being negative 1 to the k plus 1. So we have now the sum from 1 to infinity of negative 1 to the k plus 1 over k squared is equal to pi squared over 2 minus pi squared over 4, then minus the sum from 1 to infinity of 1 over k squared. But we recognize these two sums. This is just the eta function evaluated at 2, and pi squared over 2 minus pi squared over 4 is the same thing as 2 pi squared over 8, and this is the sum we're looking for minus the zeta function at 2. And we know an identity, that is the eta function at s is 1 minus 2 to the 1 minus s times zeta s. So now letting s equal 2, we have eta 2 is 1 minus 2 to the 1 minus 2 zeta 2, which simplifies into 1/2 zeta 2. So now we're going to have 1/2 zeta 2 is pi squared over 4 minus zeta 2. And now all that's left is to solve for zeta 2. So adding zeta 2 on both sides, we have 3/2 zeta 2 is pi squared over 4. Multiplying by 2/3, we have, this ends up being 1 and this ends up being 2. So we're left with pi squared over 6. So that means that therefore the sum from 1 to infinity, 1 over k squared is equal to pi squared over 6. So that is the final result. Thank you very much for watching.